Hello everyone, Simplemajority here, and this is episode 1 of Let's Play. Oh my god, so there's a video a couple weeks back where I'm talking about, how I'm going to be more on time in my videos and blah blah blah. That didn't happen. Actually, a couple things occurred. First, that day that I made that video, I had made a misstep with my foot and pulled a muscle or tore a ligament. Didn't really know what. I just know for the next 3 days, my foot was up in the air and I couldn't move. Never even went to the doctor, which is not a good thing. I'm going to see my doctor though. Anywho, shortly after that, then I got sick. Which I am still sick. So if you hear the video, the audio pause out, that's because I'm actually, or cut out, that's because I'm actually coughing. Third, I got to thinking about the game and the packs and what I do. What I want to do. And I don't want to trail behind Direwolf. No offense to Direwolf. I think he's cool, but there's a lot of mods out there that he doesn't even touch. And I think there's a lot of mods that are worth it. So that's what I'm going to do. So I've created my own mod pack. Brand new, spanking new, all on me. And we're kind of playing a little catch up because I had a bit of audio problem in my first attempt recording this. So the video was supposed to be about electrical age and getting started. And we're finishing up with the macerator and making sure everything was cutting off and turning on when it was supposed to be, and that was it. And then the episode later today would be the next episode would be about lighting. So that was what it was supposed to be about, but it didn't end up being that way. I don't think this can process 10. This machine's pretty limited in what it can do. Yeah, see, it can't do 10. Well, what else we got up here? What else you got up there, Tim? Bauxite, copper ore, gold ore, aluminum, more copper, silver. Can use the copper. Quite honest with you, some iron ore and tungsten. Okay, cool. So anyway, that was what it was about. Now we're going to go through and we're going to talk about the machines, and I wish I could have showed you, put them together and show you, but we're going to have to kind of start up here. The very beginning of your machine, your electrical age, you're going to start with this, the stone heat furnace, which is built, right here. And takes 7 stone, copper thermal cable, and a combustion chamber. The combustion chamber is just 4 stone and a diamond. And the copper cable, thermal cable, is... No. You have done wrong. So go up here. It's 6 cobblestone and then copper ingots. Or you can just take a copper wire and just combine it with a cobblestone, like so. And it gets you a 1-to-1 recipe. So, alright. So what this guy does, this guy has an interesting UI. This here is where we're going to put our fuel, obviously. We have this control, which is called external. It's set, when it starts up, it's on internal control, and this one's lit up. It says decline fuel. And you have these 2 sliders, which is regarding our temperature and our power output. Right now it's at 10% power output. And current temp in here is 29.6 Celsius. Now this thing will get hot, but we're limiting how hot it can get. We're also using external control, which means it's actually being controlled by this signal cable right here. And if I check it right now, it's going to be a value of 0.0. We can see that on the screen right here as well. We'll come back to these in a bit, so not leaving anybody out here. Anyway, so we're going to put our fuel in, and we're going to turn, when the machine comes on, it's going to pass the fuel, or the heat, it's going to burn the fuel, passing all that heat through this wire right here. And you can see right now it's at 29 Celsius. And that's going to pass it into this machine, the furnace. Now when you place the furnace in the world, you'll notice here a red border and then a blue border. When you place it, you always go like this. So the heat furnace is always on my left, and I place it, and I always get you the right position. Otherwise, you can simply just use your screwdriver to rotate it, or you should be able to. I guess it won't let me. Anyway, so all the heat passes through this thing. That's what's going to turn, it turns over and creates electricity to go out. The remaining heat passes through this and into this small passive thermal dissipator. So, now, over here, we have a low voltage cable, because we're working with a 50 volt turbine, which is low voltage. We don't need anything higher. We're not really cooking higher. Low voltage cables are capable of supporting, I'll need some anyways. There we go. So low voltage cables are capable of supporting up to 1,000 watts of power, and at a current of 20 amps. But the voltage can never exceed 50. So this is passing through here and on up to here to this battery. Now the battery also is transmitting power both ways. It's coming from here and from the battery. That transmits power to this macerator. So, excuse me, that one I'll let go through because it wasn't too bad. Anyways, so the power is passing through these devices, these electrical probes. Now I've got two of them. The first one here is monitoring the temperature, or the power. Thunderstorm. So what it's looking at is the wattage passing through, and it's going to attempt to keep it between 210 and 250. That controls and regulates the temperatures through here. This side over here is actually going to just monitoring voltage, and I have it set to 100. You can set it to any value you want, but 100 is fine. These little guys here are signal cables. To make these, you're going to need... There you go. Oh, no. Sorry. Come here. There you go. So you either use 6 rubber and 3 iron, and it gets you 6, or 1 iron cable with 1 rubber. And you can just make this. You just make this, and without the rubber. So, okay. Okay. So what is happening is we come up here, we have a recipe, or a formula in this thing. This is called a signal box, or signal processor. And these are made by, here we go, 4 signal cables, 4 iron ingots, and you need a cheap chip, which is 4 redstone round silicon ingot, which is crafted by silicon dust, or smelting silicon dust, which you get by macerating sand through a macerator, and it says ELN, which means this guy. You must use the 50 or 200 volt macerators to make the silicon dust. It won't work in any other machine. So, anyway, so let's talk about the formula. We have C times RS, and in parentheses we have A greater than 0.54, and then comma A less than 0.54, and then the end of parentheses. So what this actually is a reset, a reset set formula. And what it's doing is it's evaluating from the A, which is this one here, the red. We can mouse over and it'll say inputs are A, B, C, red, green, blue. Boom, there's blue, and then green is here at the bottom, obviously, and it's off because nothing's connected. So it's monitoring A. Okay, so it's looking at this line here. What is this line running at? Right here. Right now it's at 54.6 volts even. Okay, so that's good. That's right where we want it at. It's cut off. If I go put some items in the machine, we'll start tearing things up. You're going to notice that the voltage will begin to go down. So now it's at 51.8. So to get this thing to turn on, we need it to be to actually go less than 0.45. So when this reaches 45 volts of electricity, it's going to turn on, or it's going to emit its signal. Right now it's at 51%. And you notice here it says 25.8 volts. Ignore that. It doesn't work. It's not what you want to read your number on. You want it right here from this probe. Now, when all sides are true, this will say value 100%. which will send a signal all the way around to here, to this screen, and you'll see the bar jump up to 100%, and that means that this machine is now active again. Okay, and likewise, once it hits 54.6 or 54 volts, it will shut down. The signal will cease. This will drop back to 0, and this will all shut down safely. And it's designed to protect us. Now, this whole thing was inspired from the tutorial for Electrical Age, which you can download the maps with the mod. So, pretty cool. You can see we're actually pulling 206 watts out off of this guy right now. And over here, this thing is using about 200 watts. So we're losing between here and here. That's 1, 2, 3. We're losing 6 watts of power. So 2, 4, 6 watts. You have to remember here, electrical wires do lose, are resisted, and they will lose strength as you carry the signal. So it's working perfect here. It's actually running just a little shy, but that's because the battery is starting to deplete. If we check a quick check of our all meter, you'll notice it's at 49.5. We still need 45 to get started, so going to take a little more. Now, that's all cool. Let's go over here and talk about this. This is the computer display. And to make this, you simply need a cheap chip, 7 rubber, and a glass pane, and that makes this. Now note, there's 2 additional ones, the modern and the industrial data logger. These do not have recipes. They are not craftable. But I don't see anything that says you can't bring them into the game. If I have cheat mode enabled, I can do this. I can come over here, and we'll set this right here, and we'll rotate that into position right there, and you can see now it's actually reading. Now I'm not going to leave it sitting there because it's not a proper spot, because you can see it's just not right the way it's set up, and I can't put it any closer to this or we'll get an interference. But I'm still working on an idea for that. So there we go. And likewise over here, we can do another one of these. Now this one we could go with the other one. Let's look at the other one. The modern data logger. There we go. And it's just like the regular computer, input from the back. Remember, our cutoff is 250. So let's set our bracket at 500. Ooh, not 50,000. Not even 5,000. In power. Now that should not be producing that much power. Energy joules, percent, amperes. Interesting. You should not be producing like 500 watts. You're producing what? Huh? You're producing 194 watts of power. Where are you getting 500 watts from? I feel this is an error. And it's forth why we don't want to use these. They might be broken. They're work in progress. Let's try this and see if it kicks in right. I'm going to put it at 1,000. So yeah, we're not pulling 1 gigawatt of power at all. Not at all. Not at all on this. So that's not right. And what it's actually evaluating is the value. So right here, this value is 100%. And that's what it's reading. So here, it's reading 49 something. Let's check, dump a little more in here. Do some tungsten now. We check over here, you'll notice, hey, looky there, power's on. Oh, hey, we had a little dip too. Which we actually see. You can also I don't know how it works. I haven't tried this feature yet, but supposedly you can insert paper in here. There we go. And we can print this data logger. Now, I don't know what you can do with that, but you can print it. So that's kind of cool. Don't exactly know what you can do with it, though. That's just, maybe it's something for the future. Anyway, so yeah, this display here is looking at that measurement. Now we could change that by changing this value. So we'd have this to produce the 100%, and we can set that to say 500. But we're not doing that because we're monitoring the power coming from here, and that's what's helping control the temperatures here. See here, it's holding at 259 Celsius. And likewise over here. Now, this is still charging. It is charging, but at a very slow rate. And that's because this is still running. This is taking 197 watts of power, so whatever's left over is transferring to the battery. Yeah, I know, these don't run very fast. Why? Well, because these can actually be boosted. I'm just going to show you, and I want to see what the effects are. I'm going to despawn them afterwards. But I'm kind of curious. We need, here they are, the machine booster. To make these, we'll have to get off here. Here it is. We need 2 electric motors, which are made with 3 iron ingots, 3 low voltage wires, and an advanced chip, which is a basic cheap chip plus 4 redstone plus 4 silicon ingots. Okay, we'll go ahead and grab one of these. We're already out of fuel, or whatchamacallit. Drop that in there and watch what happens. So I want to look at the power. So it actually, look what it's doing. It's actually taking more power, 275 watts worth. But it is moving quicker. Now over here, this guy, our 50 volt turbine, maximum out power is 300 watts. We can't get better than 300 watts. So if I wanted to, I can come over here and set this to 250 and this to 300. Ooh, not 3000. Validate that. Now we should see a temperature increase. Temperature's going to start climbing a bit. We should also see a power increase of the power as it goes. So right now it's putting 223, and this is no longer is outputting, so it's now in discharge mode. So that's what that does. Speeds it up, but at the cost of your power generation. So cool. And you see this is still holding at 223. And that is correct, 250 by 2 to 2K. Maybe it's this way. So you see it's still climbing, but at a very slow pace. So 224. I think it's supposed to have been that way. But you can see our power output as it fluctuates up and down. Now eventually, once this thing is fully charged, the whole thing will shut back down again. What you want to be careful of, though, and this is very important, is that you don't overload your system. Now, over here at the battery, we can support up to 1000 watts or 1 kilowatt of power of usage. But if we come over here, we're only generating up to 300 watts. Right here. That's it. So that's actually still low. So we can actually only generate about 300 watts of power. Now, to get where we need to be with our power inputs and outputs, we would have to build more of these. So eventually this whole thing's going to get shifted around and moved. Oops, get you out of here. I'm going to have to move this down because I'm going to have to build more turbines and more heat furnaces and more cooling systems and so forth to handle and accommodate the power needs of our facility. And eventually we'll even step into 200s. I think once I get 4 of these up and running, then I'm going to probably step into a 200 watt system. And 4 times 300 is 1200 kilowatt, or 1.2 kilowatts of power, which is more than this machine can handle. But it should be okay. This definitely. But it will, no matter what the voltage, it's really the voltage that matters. Especially this. So that's where we're at. And so far looking pretty good. And what I'm thinking of doing, this is what I'm thinking of doing. What I'm thinking of doing is, I have to build this. If I build this, and let's say trade, I don't know, equivalent, basically what I call an equivalent trade. I drop one of these into here, and I drop, let's say, a diamond. Then I can get myself a modern data logger. If I drop an emerald, then I can get myself the industrial. And I do like the look of the industrials. I mean, they look so nice on the walls. Look, I mean, doesn't that look nice? Isn't that so much prettier than this bulky monitor sitting here? I mean, it's beautiful. Now, another thing in this regards before we cut the video is the wiki. If you press the X key by default, mine is on the N key, it'll pull up the wiki, and you could search up all the recipes right here. Now, they don't have any IR interaction, so you can't transfer them. But you can see stuff like modern data logger. If you click, and it'll say, is not craftable. Is not a crafting material. Okay, so in other words, sawed off. Come up here, same thing with the industrial, unfortunately. There's another object that we can't craft either, and that is located right here, the Modbus RTU. Not craftable. Don't have any idea what it does, so don't ask. Alright. Pretty much, though, beyond that, I think everything else is craftable in the mod. Yeah, I think so. But you can access all this right here. So if you need to learn how to make something, and you can't find it in EI, or you want some better information, you can go ahead and get that. Like, you know, here. All it does is show you how to make it. Which is what NEI does for you, so. Uh-oh, here comes that cough. Okay, and I'm back. So the last thing that I made in the video, well, one of the last things is the all meter. Right here. To make this, you need a multimeter and a thermometer. To make the thermometer, or multimeter, 6 pieces of rubber, a voltage chip, redstone, and a glass pane. And the voltage chip is 4 redstone with high voltage cable. The thermometer is exactly the same, with the exception of it being a thermal chip, which is made with 2 copper, iron, and 2 redstone. There we go. Combine the 2 together and you get the all meter. Cool. And then you also have the wireless analyzer, which is for the wireless systems, which we're not doing just yet. That's right up here. We're not doing those just yet. We don't have enough power to be doing those just yet. So that's all I made in the video. And what we were going to be getting into in the next video would be lighting, which is where I said you need to be careful and you need to make sure you have enough power generation for this so that you keep up, because lighting takes a lot of your power. And we're going to probably down here put these fluorescent lamps in. They're just 3 iron. And actually, I'm going to place them, show you what they look like, because they look really cool. Whoops. There we go. 9 of those. What we'll do is we'll come out and break all the torches in this area, and then I'm gonna start placing these guys. But one definitely, I think it's 4-spot radius. So 1, 2, 3, 1, 2. Okay, so right there. Isn't that cool looking? 1, 2, 1, 2. Boom. 2, 1, 2. Boom. 2, 1, 2. Boom. 2, and then I'll be able to see how it looks in the end. 2, 2, boom. There we go. So we'll just place these out like so. Now I'm not going to get into it because I'm running a little dry on materials. I am pretty close to getting all my materials back, but still just running a tad close to be 1, 2, boom. Okay, there we go. To be able to keep doing this. So, but lights, there we go. Need a couple things. We'll need a lamp supply. We can wire do in a couple of different ways. We can use wire systems to connect them, or we can use a lamp supply, which is my preferred way of doing things. Is a lamp supply, which is made pretty simply. Oops. Again, can't do that there. 4 iron plus a copper. You can just name the channels. We'll have a couple of these channels. One will be called Underground 1 or B1 for the basement, and then Surface or Surface or Surface. Well, we'll figure it out for the upper level. The difference between these two will be that the upper level will actually have, up on the roof somewhere, we'll have a daylight sensor, which will be in a wireless transmitter, which will transmit data back down here to a relay, opening and closing it based on what time of day it is. The subterranean area, though, will always be lit up, and we will light them once we'll go back over here. So we need 2 other things. We're going to need a wire. And we also need a light bulb. We have different choices for that. Let's get that out of here. Okay, we can do an incandescent, which lights 12 blocks. Uses 20 watts of power. In normal life, about 8 hours. We can use that's a small one. This is the regular one, which it needs 30 watts and same amount, 8 hours a day. Then you have the 200 volt ones, which we can't use yet. Then we have the small carbon incandescent, which is 11 blocks, 15 watts power, and lasts for 2 hours and 40 minutes. And then the regular one, which is 13 blocks and 25 watts of power. Then we have the small economic light bulbs. These are 12 blocks, 10 watts of power, and last for 32 hours. And then the regular one is 15 watts of power at 32 hours. Finally, we have the farming lamp, which there's 2 versions, the 50 and the 200. It's a 15 block light, and it will need 120 watts power. They're really designed for your farms, so use those sparingly. We're going to be using the economic lights because they're more of your fluorescent light tubes. So those 2 items go in here. Remember, your light bulbs will eventually burn out. So the actual idea I'm going to do is probably seed these in alternations. Because I don't want them all to burn out at once. Then there's no light down here at all. So what I'll do is I'll go across, this row here, and then I'll go over to this row here, and skip a row, and then the next, an hour later come down, do the other rows, and alternate them out. So there's always light in this room. So we'll put those fluorescent lamp sockets down here because they look cool. It just feels like a basement, so let's make it look like a basement. Upstairs, we're going to put these guys in, the flat lamp sockets. 2 iron and a glass pane make those. And they just feel more like, a more professional looking light. See, our batteries are full. We see our systems drop down to 0%. It's no longer active anymore. Self-contained. Cool. And we can expand this. I can expand this as far as I wanted to. I could say add another couple of Another turbine, another dissipator. So here, right here, I mean 20 Celsius. Oh, well, we're not cooking yet, so. But I can add more to the system as I want, as I see fit, and it will continue to provide power and just be beautiful. What I don't know is, and I think it does, but I'm not 100% sure, but I don't know if the signal actually transfers from block to block. So if I have two of these guys right here, and then two turbines and so forth, I don't know necessarily if this signal will transfer from here into here and then over to here. I think it does. So, alright, well, that's about it. I did notice something else. Diodes. I know these can be created. 10 amp diodes. And this is only to make it where current can only run in one direction. And there's your signal diodes. And power capacitor. And then we have the power inductor. I think these are for whatchamacallit. Mod oh, I don't even know now. I'm too tired to even think. Cross mod support. I think. Don't quote me on that. Not at all. Oh, digital watch. Can't craft that yet. That sucks. Analog watch. Can't craft that. Oh, yeah, I can craft the analog watch. Oh, okay, I guess you can craft the digital watch. Cool. I wonder, what does that do? And what does it need? Oh, that's cool. What do you run off of? Oh, you need power. Interesting. Okay, so if I put you here, and then right-click that in. Ooh, maybe it's a signal. That'd be interesting if it's signal only. No. No. Well, by George, is it medium? Or it tried low, so let's try medium. No, it's not medium. The large? It can't be large. I mean, come on. Have you ever seen a clock that needs 800 volts of electricity to operate? No. Well, something else I'll need to research because I have no idea how to make that one work. It is craftable, though. It is. You know what? It runs on batteries. We don't have any charged batteries, do we? They're all uncharged. Yep. Of course, they don't like give us any charged batteries in this game, do they? Wait. No, it's dielectric gel. We don't want that. Portable battery, 500 watts. 100 discharge. Yep, so it runs on a battery. That's what it is. And unfortunately, we have no batteries. I could charge one real quick, though. Oops. Okay, we'll do this. And this is only so I can test. This is in the name of science. We need the electrical source. This is a creative item only, because we can set it to whatever we want. Yeah, it's 200 volt charge. Okay, there we go. It's on, and there we go. It's charging up. I decided to go with the 200 volt because it'll charge faster. These are cool. We'll come to these in a bit. Believe me, these are cool because they're going to tie into some of these other cool items, which I'm hoping we can use. There we go. Go ahead and take that out. And we'll remove those two guys. Goodbye. Goodbye. Hello. Drop you inside there. And oh, look at that. Isn't that cute? We have Minecraft time in the game now. Nice. That is cool. I like it. And then there's an analog version of that clock too. Awesome. So we're messing around with a lot of this stuff. We're going to have a lot of challenges, especially when we get to... I'm going to turn creative on. So a couple items, we're going to have an extreme challenge when we get to them. Let's take that out and throw the battery away too. We don't need that. Okay, we're going to need you. Here's our first challenge. Bloop. What is that? This, my friends, is a teleporter. We'll name these points, these transporters, give them destinations and stuff, and then we can actually step in and hit start, and it will send us to that location. These guys take a ton of energy to run. I mean, a ton of energy. And in fact, it doesn't even tell you. But I remember in the tutorial map, it was like, I think they had like 4 of these batteries all like chained together on 200 volt systems. Let's see here. Where is our other one? Oh, it's not in the normal spot that it usually would think it would be. That's the first challenge. That's the experimental transporter. The other challenge we're going to have is, if I can find the full thing, here it is, the auto miner. Oh wow, look at that guy. Isn't that cool? And it has a cool GUI. So we have a drill slot, we have mining pipe slots. It's got this really fresh GUI or the screen here. So when you actually start the system up, it actually looks like booting and drilling and all that. And you'll need a chest. It has to be a chest right here at the back. And what this thing will do is it literally will dig down like a certain number of blocks, and then it will expand its search area, dig area in search area. Pretty awesome. So it says here, excavate on a small radius, extract ore on a bigger radius. 10 block radius after 10 block depth. Normal voltage, 800. So we need 800 volts of electricity to make this thing run. So that's going to be our big challenges right there. Is getting those guys up and running. Obviously. Now, as I said, this system is pretty limited on what we can do. Oh, we're running right now. Cool. We can only do, literally, these materials for maceration. Copper, iron, lead, tungsten, gold, coal, alloy, cinnabar. So these are the basics. We can't do like tin or anything else. So we're going to take it to another level with another mod so that we get the rest. The idea of this game is going to be to eliminate or not use thermal expansion. That means no transposers, or not transposers, but whatchamacallit, tesseracts. We're going to use trains. We're going to use other things like ender chests. We'll use other methods at our disposal to transport items to and from our base. So that's the goal. That's our kind of our dream idea, is to stay away from thermal expansion. And hopefully we can do it between these two mods. Alright, so that's going to be it for now. I'm going to go ahead and sign off, get myself some rest, and get to work on recording episode number 2 tomorrow. Until then, I hope you enjoyed this little episode, and know that I am back. It's official now. Sickness or health, I will be recording. And y'all have yourself a great day.